Alright guys, it's Miss Summers with your notes today on volcanoes. This is day 1 of 2. Today we're going to look at different types of volcanoes and different types of eruptions and where volcanoes happen on Earth. And tomorrow we will look at the factors that can affect how explosive or violent a volcanic eruption can be. Alright, today you are going to be assigned a project that you are going to work on today. Only half of it will be done today, the other half tomorrow. All right, so we're going to pace ourselves. All right, so let's start with what a volcano is. I imagine that most of us can remember a time, or even now, if I asked you to draw a volcano, you'd be like, I know what that is, and you would draw like a mountain with some red stuff coming out of it. All right, and that's a good example of a type of volcano. But how we're going to define volcano is any place in the Earth's crust that opens up and magma erupts. All right? Anywhere where magma goes from being under the ground to the surface is a volcano. All right, and we will look at the difference between magma and lava tomorrow specifically, because we're going to be looking at that in terms of eruptions. All right, so let's look at the different kinds of eruptions that we can have at volcanoes. There's two main kinds. All right. The first one are the rift eruptions. So rift, if you remember from boundaries, a rift happens when the plates are pulling apart. So this is at a divergent boundary. Rift eruptions are generally non-explosive. So you might be saying, well, that looks pretty explosive to me, Miss Summers. What we mean by non-explosive, it means that it's not like a Mount St. Helens or a Vesuvius, Pompeii type deal. All right, this magma is flowing quietly onto the Earth's surface. All right, a good example of this would be at the mid-Atlantic ridge. Remember, ridges form at oceanic divergent boundaries, and the magma comes up and makes new crust. All right, so if we looked at a map, and we wanted to see where the rift eruptions were, I would look down here at my key. Blue is divergent, green is convergent, and yellow is transform. Anywhere where we have blue are going to be my rift eruptions. So up here at the Mid-Atlantic Ridge, in Iceland, that's where that picture on that last slide was at. Maybe a little here off the coast of like Canada and Alaska, maybe just a little bit. Mostly in the ocean. That's generally where these are. Okay? Our next type of eruption is called a subduction boundary eruption. I do not know why this word is down here. It should be up here. Subduction boundary eruption. These occur at convergent boundaries in subduction zones. So I go down here to my little diagram. I have my oceanic crust subducting underneath the continental crust because it's denser. Remember, even though ocean crust is thin, it's dense. And then the magma, the plate melts, creates magma. These are the explosive eruptions. These are like the big volcanoes that go kaboom. These are the ones that when we draw a picture of a volcano, like if you asked a little kid to draw a picture, they would probably draw an eruption like this, where it's like a mountain and a big explosion. All right. So if I look at my map again, I want to know where is this going to happen so I can be ready for it. Well, subduction boundaries are at convergent boundaries, all right? And remember, subduction only happens with oceanic crust. Okay, so I'm going to look for convergent boundaries along oceans. So there's one. Along the coast of South America, all of these are volcanoes. There's volcanoes in like Mexico and Central America. Alaska, remember this is the Aleutian Islands. There's a little trench right here. Japan, the Philippines, all right? Even over here in this kind of weird little boundary, all right, the African plate is going under the Eurasian plate. This is where Mount Vesuvius is. That's the one that destroyed Pompeii. All right? So we have our rifts eruptions at divergent boundaries and our subduction boundary eruptions at convergent boundaries. So those are the main types. And just like earthquakes, just like we talked about earthquakes last week, volcanoes tend to be at plate boundaries. okay? 9 times out of 10, a volcano is at a plate boundary. But what if they're not? You know, like, what's the exception? There's always exceptions to the rules. Our exceptions are hotspots. And we talked about hotspots already with our evidence for plate tectonics. Okay? Remember, a hotspot is a place in the mantle where magma wants to come up to the surface. That hotspot stays in one area, and as the plate moves over, it makes a little line of volcanoes. All right, these can be either explosive or non-explosive. It kind of depends on the kind of crust that you're dealing with, because that's going to change the magma, and that's going to change the volcano. Hawaii is a good example. Yellowstone's a good example. Here's our diagram of a hotspot. So Hawaii is right here. You know, 100,000 years from now, this big island of Hawaii is going to be over here, where Maui is. And Maui's going to be a little further away. And Oahu's going to be a little further away. And there'll be a new island. Okay, so that's our hotspot. So volcanoes happen at divergent boundaries, convergent boundaries, and hotspots. Those 3 places. So now we can look at the types of volcanoes that are formed. So we have 3 types. I want you to know how they're made and what they look like. All right, part of your project is going to be finding examples. Our first type of volcano is a cinder cone. So cinder cone volcanoes happen at convergent boundaries, and they are little firecracker volcanoes. They're very explosive. What happens is during an eruption, you'll get a big kaboom. The rock, volcanic ash, and these little bitty pieces of rock that were blown apart by the eruption will fall back down, and it will make a little mountain, a little cone. So it's a generally small, not super tall, but very steep. All right. There's an example in Mexico. This place is called Paricutin. I don't know if I'm saying that right. If I'm not, you can correct me. All right. But here's what it looks like. So kind of a very small, not super big, but a very cone shaped. All right. And it's made out of these cinders, this volcanic ash just falling back down after an eruption. All right. My cinder cones. Our next type of volcano are the shield volcanoes. All right. So if you think about a shield like Captain America shields, all right, they're not perfectly flat. They're kind of rounded. And this is kind of what a shield volcano looks like. These happen at non-explosive volcanoes, so you're not going to have the big kabooms. So this is going to be more at those rift eruptions at a divergent boundary or some hot spots like Hawaii. Lava quietly flows. And what we mean by quietly is kind of this number, okay? It's not this big roaring, explosion. It's just the magma's just bleep onto the surface. The magma will, now it's lava. The lava will cover a large area, and you'll end up with a dome-shaped mountain that takes up a lot of space, but it's very gentle slopes. All right, so it's very, very subtle. All right, Mauna Loa in Hawaii is an example. Basically all of Iceland is an example. So here's a good picture. I think this one is actually in the Galapagos. The Galapagos is a hot spot, but you can see it's like a dome. It's not really steep and it's not super tall, but it takes up a large area. All right, it's just made from layers of cooled lava. All right, so we have our cinder cones that are small, steep mountains. We have our shield volcanoes that are formed from the lava flows that are big, broad domes. And our last volcano are the composite cone or stratovolcano. All right, I'll use both those terms. I want you to know both. Stratovolcanoes are kind of what we think about when we think about a classic example volcano. Okay, if you think about like any major eruption like Mount Vesuvius, Mount St. Helens, Krakatoa, if you're familiar with that one, or Mount Tambora, which we're going to talk about later this week. Those are our nice big stratovolcanoes. So you have, this is at a convergent boundary, so subduction. This is a subduction boundary eruption. you have a violent eruption followed by a quiet flow of lava. So it's almost like the cinder cone volcanoes and the shield volcanoes mixed together. So you end up with a large mountain with steep sides. So it's like a super mega big cinder cone with alternating layers of lava. All right, so some examples, Mount Fuji. If you've ever seen a picture like of Japan, or like if you see a postcard from Japan, chances are Mount Fuji's in it. Mount Vesuvius, Mount St. Helens, these really big, devastating eruptions. So here's what it looks like. This is Mount Rainier in Washington State. So the reason it's called composite, or it's called a stratovolcano, strato means layer. Composite volcanoes or stratovolcanoes are made of layers of the ash that falls down after the violent eruption, and then layers of lava flowing on top of it. So that's why it gets to be really, really big. Okay? So that concludes what I want you to know about volcanoes today. We talked about where volcanoes happen. We had the rift eruptions at divergent boundaries. We have our subduction boundary eruptions at convergent boundaries. And we can have eruptions at hotspots like Hawaii or Yellowstone. And we've talked about our 3 types of volcanoes. Our cinder cone volcanoes, which are our little steep mountains made from volcanic ash. We have our big, broad shield volcanoes, which are made from layers of lava. And then we have our nice, tall, classic stratovolcano / composite, which are made from layers of volcanic ash and lava. Okay? So your job today is to go start that project. All right, you're going to be making a PowerPoint for me, so Google Slides, that's fine. You should be able to do at least the first about 4 or 5 slides. All right? So let me know if you have any questions, and I'll see you tomorrow.